Welcome to ScienceCover.com. In this session, we look at conservation of momentum. The aims of the session are to know the law of conservation of momentum and to use the law of conservation of momentum to investigate collisions, whether the objects stick together or move apart. Before we begin, pause the video and attempt the Do Now task. Let's check our answers. Number 1, what is the equation that relates momentum, mass and velocity? That is, momentum equals mass multiplied by velocity. Number 2, what are the units of momentum? That's kilogram meters per second. A child of mass 40 kilograms runs at 3 meters per second. What's the momentum of the child? So we need to do 40 multiplied by 3, and that's 120 kilogram meters per second. A car of mass 1,200 kilograms travels at 10 meters per second. What is the momentum of the car? So this time we do 1,200 multiplied by 10, which is 12,000 kilogram meters per second. A squirrel of mass 2 kilograms moves with a momentum of 14 kilogram meters per second. What is the velocity of the squirrel? Well, the velocity is the momentum divided by the mass. So this will be 14 divided by 2, which is equal to 7 meters per second. Now let's look at the conservation of momentum. The law of conservation of momentum states that the total momentum before a collision should be equal to the total momentum after a collision if no external forces have acted. So for instance, a basketball is rolled into a wall, it collides and bounces back in the opposite direction. Calculate the speed of the ball after the collision, ignoring any friction or forces. So here's our basketball heading onto the wall. It has a mass of 0.6 kilograms and it has a speed of 14 meters per second. So the momentum before the collision must be equal to the momentum after the collision. And before the collision, my mass multiplied by my velocity is 0.6 times 14, which gives me 8.4 kilogram meters per second. Now, according to the law of conservation of momentum, after the ball has struck the wall, it should maintain this momentum, 8.4 kilogram meters per second. So I can use the equation again, but this time I'll put the momentum as 8.4 kilogram meters per second. Now, because the ball will be traveling in the opposite direction, I'm going to use a negative symbol to represent that change in direction. And the mass of the basketball is still 0.6 kilograms. So the velocity is now minus 8.4 divided by 0.6, which is equal to minus 14 meters per second. Pause the video and complete task 1. Let's check our answers. State the law of conservation of momentum. The total momentum before a collision is equal to total momentum after the collision, assuming that no external forces act. Or we could say that the total momentum before equals the total momentum after. Number 2, velocities can have positive and negative values. What does this tell us about the object? This tells us about the direction of motion of the object. Number 3, a basketball is rolled at a wall. Calculate the momentum of the basketball before it strikes the wall. So here we can see the mass is 0.6 and the velocity is 14. So 0.6 times 14 is 8.4 kilogram meters per second. What will the momentum of the basketball be after it strikes the wall? Well, assuming that the wall doesn't move, then the momentum will be coming in the reverse direction, so it'll be minus 8.4 kilogram meters per second. What will the velocity of the ball be after striking the wall? it should be minus 14 meters per second. Now let's investigate how momentum changes in collisions. In these examples, we look at objects that stick together after their crash. A moving cart crashes into a stationary cart. The two carts stick together. What will the speed of the carts be after the collision? And we can see here in the diagram, we have a first cart that has a speed of v1 as 3 meters per second and a mass m1 of 0.5 kilograms. The second cart, which is crashing into, has got a speed v2 of 0 meters per second and a mass of m2, 0.5 kilograms. We're told after these carts collide, they stick together and they'll move off together. So the first thing we can do is add together their masses, and we'll treat these as one object. So 0.5 kilograms plus 0.5 kilograms gives me a mass of 1 kilogram. Now I want to find the speed that these two carts will move off with after the collision. Now applying the law of conservation of momentum, I know that the total momentum before the collision should be equal to the total momentum after the collision. This means that if I add together the momentums of cart 1 and cart 2, they should equal the momentum of the two carts after the collision. So I can write this as m1 v1, that's the momentum of cart 1, plus m2 v2, that's the momentum of cart 2, and it's going to be equal to m3 v3, and that's what I'm calling the mass and velocity of the cart after the collision. Next, substitute in the values that we have. 0.5 multiplied by 3 plus 0.5 multiplied by 0. And we also know that the mass of the two carts together, m3, is 1 kilogram. So we can call this 1 times v3. This means that we have 1.5 plus 0, and it's equal to v3. This means that v3 is equal to 1.5. So the two carts after the collision move off with a velocity of 1.5. A moving cart crashes into a second slower cart travelling in the same direction. The two carts stick together. What speed will the two carts move after the collision? So again, we can add the two masses together since they stick together and work out that m3, the mass after the collision, will be 1 kilogram. I'm interested in finding the velocity of the carts after the collision. So again, I can use the conservation of momentum. Total momentum before the collision is equal to total momentum after the collision. This is m1 v1 plus m2 v2, and it must be equal to m3 v3. If we substitute in the numbers that we have, 0.5 times 3 plus 0.5 times 2, and this must be equal to 1 times v3. Now this time we have 1.5 plus 1 equals v3. So v3 must be equal to 2 meters per second. In this example, we can see how having a positive or negative number allows us to tell what direction the cart is heading in. So we have again a moving cart crashing into a second cart, this time travelling in the opposite direction. The two carts stick together. What speed will the two carts be after the collision? And we can see that cart 1 has got a mass
0.5, but a velocity of 3 meters per second. This means that it's moving to the right. Whereas cart 2 has a mass of 0.5 and a velocity of minus 4 meters per second. This means that it's moving to the left. We know that afterwards they stick together. So this means we have a mass of 1 kilogram, but we don't know what the speed of them is. To work this out, we again use the conservation of momentum. The total momentum before the collision is equal to the total momentum after the collision. m1v1 plus m2v2 must be equal to m3v3. This time when we substitute in the numbers, we'll pay attention to whether they are positive or negative values. So we have 0.5 multiplied by 3, 0.5 multiplied by minus 4. And this is going to be equal to 1 multiplied by v3. Now if we calculate these values, we find that it's 1.5 plus minus 2. And this is equal to v3. So therefore v3 is equal to minus 0.5 meters per second. So this means after the collision, the two carts stick together and move at a speed of 0.5 meters per second to the left. Pause the video now and complete task 2. Let's check the answers. The diagram shows the collisions between different carts. Calculate the velocity of the cart after the collision. So here we know that the momentum before the collision must be equal to the momentum after the collision. So therefore m1v1 plus m2v2 must be equal to m3v3. This means 0.5 times 0.5 plus 0.5 times 0 is equal to 1 times v. So this is 0.25 plus 0 is equal to v. And that means that v must be 0.25 meters per second. In part B, the first cart is moving with a speed of 5 meters per second to the right, but the second cart is moving with a speed of 6 meters per second to the left. So we're going to call this speed minus 6 meters per second. Again, the momentum before must be equal to the momentum after. So m1v1 plus m2v2 must equal m3v3. So 0.5 times 5 plus 0.5 times minus 6 is equal to 1 times v. This gives us 2.5 plus minus 3 is equal to v, and therefore v must be equal to minus 0.5 meters per second. In C, we're asked to calculate the mass of M2. Well, if M1 has got a mass of 2 kilograms, and the mass after they've stuck together is 5 kilograms, then M2 must have a mass of 3 kilograms. Calculate the velocity of the carts after the collision. The momentum before the collision must be equal to the momentum after the collision. So m1v1 plus m2v2 must be equal to m3v3. This is 2 times 3 plus 3 times minus 2 equals 5v. So that gives us 6 plus minus 6 is equal to 5v. So 0 equals 5v. So therefore v must be equal to 0. Which means that as these collide, in the after case, there is no motion and the two carts are not moving. Now let's have a look at collisions where the carts move apart. A moving cart crashes into a second cart travelling in the opposite direction. The two carts bounce apart. So we draw this as two separate carts, cart 3 and cart 4, and we'll give them values of M3, M4, V3 and V4 for their mass and velocity. So we can see that they came together in the before case because the speeds are 3 meters per second and minus 4 meters per second. And in the after case, they're moving apart where V3 is minus 2 meters per second. We're trying to work out what V4 will be. So the total momentum before the collision has to be equal to the total momentum after the collision. This means now that M1V1 plus M2V2 is going to be equal to M3V3 plus M4V4. If we substitute in the values, we've got 0.5 times 3 plus 0.5 times minus 4. And in the after case, we've got 0.5 times minus 2 plus 0.5 times V4. So this is 1.5 plus minus 2, and it must be equal to minus 1 plus 0.5 V4. So this means that minus 0.5 is equal to minus 1 plus 0.5 V4. If we add 1, then we have 0.5, and this is going to be equal to 0.5 V4. So if we now divide by 0.5, then we get V4. And so V4 must be equal to 1 meter per second. A basketball and a bowling ball are thrown together as shown. Calculate the speed of the basketball after the collision. So here we have a basketball with a mass of 0.6 and travelling at 7 meters per second, colliding with a bowling ball with a mass of 1.5 kilograms, travelling at minus 4 meters per second in the opposite direction. The total momentum before the collision must be the total momentum after the collision. So therefore M1V1 plus M2V2 still must be equal to M3V3 plus M4V4. We can substitute in the numbers that we have and try to work out V3. So this gives us 4.2 plus minus 6 is equal to 0.6 V3 plus minus 0.75. That's minus 1.8 being equal to 0.6 V3 minus 0.75. If I now add the 0.75, then that gives me minus 1.05, and that's equal to 0.6 V3. So if I divide by 0.6 to get V3, then I get an answer of minus 2.8 meters per second. Pause the video now and complete task 3. Let's check the answers to task 3. The diagram shows a collision between two trolleys. Calculate the value of V4. So the total momentum before must be equal to the total momentum after. This means M1V1 plus M2V2 must be equal to M3V3 plus M4V4. Substitute in the numbers that we have, and we end up with 2.5 plus minus 2 equals minus 1.5 plus V4. So therefore V4 must be 0.5 plus 1.5, which is equal to 2 meters per second. The diagram shows the collision between a basketball and a bowling ball. calculate the value for V3. So we know the total momentum before must be equal to the total momentum after. This means M1V1 plus M2V2 is equal to M3V3 plus M4V4. Substitute in the values that we have 1.5 plus minus 3 is equal to 0.5V3 plus minus 0.3. Now this is minus 1.5 equals to 0.5V3 plus minus 0.3. If we add 0.3, then we get minus 1.2 equals 0.5V3. So if we now divide by 0.5, then we have 2.4, and that must be equal to V3. So V3 is equal to 2.4 meters per second.